When determining the proper conductor size for electrical installations, especially in wet locations, it is crucial to understand and correctly apply the ampacity derating factors as outlined in the National Electrical Code, or NEC. The NEC provides tables and guidelines to ensure that conductors operate within safe temperature limits, preventing overheating and potential fire hazards. Specifically, when dealing with conductors like THHW and XHHW, which have dual temperature ratings for dry and wet locations, the selection process requires careful attention. Table 310.13 of the NEC lists these conductors with a 90°C rating for dry locations and a 75°C rating for wet locations. The question arises whether it is permissible to start with the 90°C rating in a wet application, apply the necessary derating factors, and then ensure the final ampacity does not exceed the 75°C limit. However, the correct approach, as mandated by the NEC, is to always begin with the 75°C rating for wet locations and apply the derating factors from that starting point. Understanding why this approach is necessary involves delving into the principles of ampacity derating and the specific conditions that affect conductor temperature. Ampacity, which is the current carrying capacity of a conductor in amps, is determined by the conductor's ability to dissipate heat without exceeding its insulation's temperature rating. Several factors influence a conductor's operating temperature, including the ambient temperature, the number of conductors bundled together, and the presence of thermal insulation. In wet locations, the presence of moisture significantly affects the conductor's ability to dissipate heat. Water, being a better thermal conductor than air, can both help and hinder heat dissipation. While it might seem that water could help cool the conductor, the reality is more complex. The presence of moisture can lead to corrosion and degradation of the insulation, reducing its ability to withstand high temperatures over time. Additionally, the NEC defines wet locations as areas subject to saturation with water or other liquids and unprotected locations exposed to weather. This means that conductors in these locations are likely to be continuously exposed to moisture, exacerbating the effects of heat and corrosion. Derating factors are applied to reduce the allowable ampacity of a conductor when it is installed in conditions that impede heat dissipation. These conditions include high ambient temperatures and the bundling of multiple conductors in a conduit or cable. The NEC provides tables, such as those found in Article 310.15 and its associated tables, to determine the appropriate derating factors based on the specific installation conditions. For example, if multiple current-carrying conductors are installed in a single conduit, the heat generated by each conductor can raise the overall temperature within the conduit. This necessitates a reduction in the allowable ampacity of each conductor to prevent overheating. Similarly, if the ambient temperature exceeds the reference temperature specified in the NEC tables, a derating factor must be applied to compensate for the reduced heat dissipation. The NEC specifies that for conductors in raceways or cables exposed to direct sunlight on or above rooftops, an additional temperature adder must be applied to the ambient temperature before derating. This adder accounts for the increased heat absorption due to solar radiation, ensuring that the conductors are adequately protected against overheating. When applying derating factors, it is essential to follow the specific guidelines provided in the NEC. These guidelines typically involve multiplying the base ampacity of the conductor by the appropriate derating factors. The resulting value is the adjusted ampacity that must not be exceeded under the given installation conditions. In the case of THHW and XHHW conductors in wet locations, starting with a 75°C rating is not merely a suggestion but a requirement. This requirement is based on the fact that the insulation properties of these conductors degrade more rapidly in the presence of moisture at higher temperatures. By limiting the maximum operating temperature to 75°C, the NEC ensures that the insulation maintains its integrity and provides adequate protection against electrical faults. To illustrate this point, consider a scenario where a THHW conductor is installed in a conduit buried underground in a wet location. The conductor is part of a circuit that supplies power to a submersible pump. According to Table 310.16, a 12 American wire gauge, or AUG, THHW conductor has an ampacity of 30 amps at 90 degrees Celsius and 25 amps at 75 degrees Celsius. However, since the location is wet, the 75 degrees Celsius rating must be used as the starting point. Now suppose there are 6 current-carrying conductors in the same conduit. According to table 310.15 cone, the derating factor for 4 to 6 conductors is 80%. Applying this derating factor to the 75 degrees Celsius ampacity rating yields an adjusted ampacity of 25 amps multiplied by 0.80, which equals 20 amps. This means that the 12 AWG THHW conductor in this specific installation can only carry a maximum of 20 amps without exceeding its safe operating temperature. If the initial calculation were erroneously based on the 90 degrees Celsius rating, the adjusted ampacity would be 30 amps multiplied by 0.80, which equals 24 amps. This higher value could lead to overheating of the conductor, potentially damaging the insulation and creating a fire hazard. Furthermore, consider the impact of ambient temperature on conductor ampacity. If the ambient temperature in the underground conduit exceeds 30 degrees Celsius, an additional derating factor must be applied. For example, if the ambient temperature is 40 degrees Celsius, table 310.15 bone indicates a derating factor of 0.91 for conductors with a 75 degrees Celsius rating. Applying this factor to the previously derated ampacity of 20 amps yields a final adjusted ampacity of 20 amps multiplied by 0.91, which equals 18.2 amps. This demonstrates how multiple derating factors can significantly reduce the allowable ampacity of a conductor, especially in challenging environmental conditions. It is also important to consider the voltage drop in conductors, particularly in long runs. Voltage drop occurs when the voltage at the load end of a circuit is lower than the voltage at the source end due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction and reduce its efficiency. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, it may be necessary to increase the size of the conductors. This is especially important in circuits with high current loads or long distances between the source and the load. In addition to ampacity and voltage drop, the NEC also addresses the proper installation and protection of conductors in wet locations. Section 314.15 requires that boxes and fittings in wet locations be listed for use in such environments. These boxes and fittings are designed to prevent water from entering and damaging the electrical connections. Furthermore, Section 300.6 requires that raceways and enclosures be made of materials suitable for the environment in which they are installed. In wet locations, this typically means using corrosion-resistant materials such as PVC or stainless steel. The NEC also provides specific requirements for grounding and bonding in wet locations. Proper grounding and bonding are essential for preventing electrical shock hazards and ensuring the safe operation of electrical equipment. Section 250.104 requires that all metal enclosures and raceways be bonded together to form a continuous electrical path to ground. This helps to minimize the potential for voltage differences between metal parts, reducing the risk of electric shock. Moreover, ground fault circuit interrupters, or GFCIs, are required in many wet locations to provide additional protection against electrical shock. GFCIs are designed to detect small imbalances in current and quickly disconnect the circuit, preventing serious injury or death. In summary, when selecting conductors for wet locations, it is imperative to adhere to the NEC guidelines and start with the 75 degrees Celsius rating for THHW and XHHW conductors. Applying the appropriate derating factors for conduit fill, ambient temperature, and other environmental conditions is crucial for ensuring the safe and reliable operation of electrical systems. Ignoring these requirements can lead to overheating, insulation damage, fire hazards, and potential electrical shock risks. Always consult the latest edition of the NEC and seek guidance from qualified electrical professionals to ensure compliance and safety. Remember that electrical codes and standards are in place to protect people and property from the hazards associated with electricity. By following these guidelines, we can create safer and more reliable electrical installations for everyone. Furthermore, consider the importance of using appropriately listed and labeled equipment. Underwriters laboratories, or all, and other nationally recognized testing laboratories, or NRTLs, test and certify electrical products to ensure that they meet safety standards. Using UL-listed or NRTL-certified equipment provides assurance that the products have been evaluated for safety and performance. When installing electrical systems in wet locations, pay close attention to the details of the installation. Ensure that all connections are tight and secure, and that all components are properly protected from moisture. Use waterproof connectors and fittings where necessary, and seal any openings or penetrations to prevent water from entering the enclosures. Regular inspection and maintenance of electrical systems in wet locations are also essential. Check for signs of corrosion, water damage, or loose connections. Repair or replace any damaged components promptly to prevent further deterioration and potential hazards. Consider the use of corrosion inhibitors and protective coatings to extend the life of electrical equipment in wet locations. These products can help to prevent corrosion and protect the metal surfaces from moisture and other environmental factors. Also, consider the benefits of using energy-efficient electrical equipment in wet locations. Energy-efficient equipment can reduce the amount of heat generated, which can help to improve the overall safety and reliability of the electrical system. For example, LED lighting is much more energy efficient than traditional incandescent lighting and produces significantly less heat. In conclusion, selecting the correct conductor size and applying the appropriate derating factors in wet locations is a critical aspect of electrical safety. Always start with the 75 degrees Celsius rating for THHW and XHHW conductors, and carefully consider all environmental factors that may affect the conductor's operating temperature. By following the NEC guidelines and using appropriately listed and labeled equipment, we can ensure that electrical systems in wet locations are safe, reliable, and energy efficient. Remember to always prioritize safety and seek guidance from qualified electrical professionals when working with electricity. Ignoring these precautions can have serious consequences, including electrical shock, fire, and property damage. Take the time to educate yourself about electrical safety and follow best practices to protect yourself and others from harm. Electrical safety is everyone's responsibility, and by working together, we can create a safer and more reliable electrical environment for all. The principles discussed here extend beyond just THHW and XHHW conductors. The same logic applies to other conductor types with dual ratings or specific wet location limitations. Always consult the relevant NEC tables and follow the manufacturer's recommendations for the specific conductor being used. For example, some conductors may have specific restrictions on their use in direct burial applications or in contact with certain chemicals. Understanding these limitations is crucial for ensuring the long-term performance and reliability of the electrical system. Furthermore, remember that the NEC is a minimum standard. In some cases, it may be necessary to exceed the NEC requirements to provide an extra margin of safety or to meet specific project needs. For example, in critical applications such as hospitals or data centers, it may be prudent to use larger conductors or to install redundant systems to ensure uninterrupted power supply. The NEC is updated regularly to reflect changes in technology and industry best practices. It is essential to stay informed about the latest revisions to the code and to ensure that all electrical work is performed in accordance with the current requirements. Many jurisdictions require continuing education for electricians to ensure that they are up to date on the latest codes and standards. Taking advantage of these educational opportunities is a valuable way to enhance your knowledge and skills and to stay ahead of the curve. Also, remember that electrical work can be dangerous, and it is essential to take appropriate precautions to protect yourself from harm. Always de-energize circuits before working on them and use appropriate personal protective equipment, or PPE, such as gloves, safety glasses, and insulated tools. Never work alone, and always have a qualified person nearby who can provide assistance in case of an emergency. Electrical safety should be a top priority for everyone, whether you are a professional electrician or a homeowner performing minor repairs. By following safe work practices and adhering to the NEC guidelines, we can all help to prevent electrical accidents and injuries. Finally, consider the long-term implications of your electrical installations. Electrical systems are expected to last for many years, and it is essential to design and install them in a way that will ensure their continued performance and reliability. Use high-quality materials and components, and follow best practices for installation and maintenance. Regular inspection and maintenance can help to identify and address potential problems before they become serious, extending the life of the electrical system and reducing the risk of costly repairs. In addition, consider the environmental impact of your electrical installations. Use energy-efficient equipment and practices to minimize energy consumption and reduce your carbon footprint. Dispose of electrical waste properly and recycle materials whenever possible. By making environmentally responsible choices, we can help to protect the planet for future generations. Understanding the nuances of electrical codes, ampacity derating, and environmental considerations is crucial for anyone involved in electrical design, installation, or maintenance. By staying informed, following best practices, and prioritizing safety, we can create electrical systems that are safe, reliable, and sustainable.